everyone. We are the first group with the following members, and we are going to be tackling all about the industrial gases industry.
In this part, we will be tackling a brief description and history of the industrial gases. Of course, the industrial gas industry utilizes industrial gases. But what are these industrial gases? Now, industrial gases include but are not limited to hydrogen, oxygen, nitrogen, carbon dioxide, acetylene, and the noble gases such as helium, neon, argon, krypton, and xenon. The way that these gases are manufactured differ per industrial gas. Atmospheric gases can be produced via air. Now, the industrial gas industry, of course, produces industrial gases. But what are these industrial gases? These include but are not limited to hydrogen, oxygen, nitrogen, carbon dioxide, acetylene, and the noble gases such as neon, helium, argon, krypton, and xenon. Now, the thing that makes these gases industrial gases is that they can be produced industrially. Now, there are various methods being employed in the production of gases, and one of which are air separation processes. These include cryogenic distillation, membrane separation, and adsorption. These methods employ a mixture of various gases and take them and produce a single high-purity gas as a product. Another are catalytic processes such as in the chlor-alkali industry of producing hydrogen gas, and another are as byproducts of the utilization, the mining, and the processing of various hydrocarbons and natural gas products such as the case of helium. Now, prior to these modern processes of producing gases industrially, there have been many historical undertakings to produce gases in the industrial scale. In 1889, Carl Gustav Romenholler first produced carbon dioxide from the combustion of coke. In 1890, fuel cells which were utilized to produce hydrogen were first used to produce oxygen gas. In 1891, in his attempt to produce pure aluminum, James Turner Moorhead accidentally produced acetylene. Now, the first patents for the Hampson-Lind cycle, which liquefies gases for air separation, were first filed by William Hanson and Carl von Lind in separate dates in 1895. This then would serve as the basis for the Lind process, an important process in air separation. During the 1900s, this Lind process was first utilized to produce high-purity oxygen. And in 1908, Georges Claude of Air Liquide patented the process for separation of neon from the atmosphere. In 1909, the Lind-Frank-Caro process was then first utilized to produce hydrogen gas. In 1917, the first plant to isolate helium was built by the British in Ontario, Canada. This was monumental as helium was very hard to produce during that time. And during the 1930s, Matthias Frankel's principle of regeneration allowed for the production of krypton and xenon.
We can take into account that the industrial gases industry encompasses a wide range of gaseous materials that are extremely necessary for different utilizations, such as oil and gas, petrochemicals, powder, mining, metals, environmental protection, pharmaceuticals, electronics, aerospace, and more. With its salient uses, a lot of companies have been devoted in their production, and some of which are AJAAB, Air Gas and Air Liquide, Gulf Cryo, the Lind Group, the Messer Group, Paraxair, and a lot more. To dive in further to some of the aforementioned, we can take a look at firstly, the Lind Group. Linde is a global multinational chemical company and it is the largest industrial gas company by market share and revenue. It is founded in 1879 and has been operating for almost 142 years already. Its headquarters is located in Ireland and its founder is named Carl von Linde. Nonetheless, the current CEO is Steve Angel. The company has two principal business areas: the gas, which includes industrial gases and medical gases, and engineering, procurement, and construction. Specifically, their products in terms of the gases ranges from hydrogen, acetylene, carbon monoxide, carbon dioxide, shielding gases for welding applications, noble gases and specialty gases, oxygen, nitrogen, and argon, all of which are manufactured in Linde's air separation plants. Moreover, Linde Healthcare provides pharmaceutical and medical gases products and services for healthcare industry, such as oxygen therapy, aerosol therapy, anesthesia, and gas for chronic obstructive pulmonary diseases, asthma, sleep apnea, and pain. Moving forward, we have the Messer Group GmbH. The Messer Group GmbH is a supplier of industrial gases that is focused on 30 European and Asian countries. It is established in 1898 and has been around 153 years already. Its headquarters is located in Bad Soden, Germany, and its founder is named Adolf Messer. Initially, the company is an engineering electrical lighting company. Nonetheless, between 1997 and 2004, the gas and welding-related divisions were brought forward by the Messer family. Messer is selling gases for industrial use such as oxygen, nitrogen, argon, carbon dioxide, hydrogen, helium, shielding gases, and gases for medical use. Lastly, for the international company, we have the Gulf Cryo. Gulf Cryo is a Middle Eastern company that supplies industrial, medical, and specialty gases. The group comprises of 30 companies in the MENA or Middle Eastern and North African region. It is also considered as the leader in the gas industry in this region and is founded in 1953 by Salim Hamidi. Its headquarters is located in Kuwait. Gulf Cryo produces and supplies industrial gases namely acetylene, argon, carbon dioxide, helium, hydrogen, oxygen, and nitrogen. The company also produces medical gases including medical air, medical carbon dioxide, medical nitrogen, medical nitrous oxide, and medical oxygen. After looking at the multinational companies, we can then take a look at the local ones. First, we have here the Pilipinas Trade Gas Incorporated. Pilipinas Trade Gas Incorporated was established in 1995 and is an affiliate of the Tamok Group. Its headquarters is located in East Science Avenue, Laguna, and is referred to as the leader in the production and distribution of industrial gases and gas for medication in the country and in Japan. Their products are categorized into three: gas products, which include the following: construction work, which involves the following respectively, and other gas-related materials such as gas flow meter, gas scrubber, and the like. Next, we have the Aura Oxygen Corporation. Aura Oxygen Corporation is a 100% Filipino-owned corporation engaged in the production and distribution of industrial gases and medical gases, as well as liquefied petroleum gas or LPG. This company is established in 2006 and its headquarters is located in Makati, Philippines. Nonetheless, the incorporators are from Cagayan de Oro City, therefore the company name. Their main products involve oxygen, acetylene, LPG, nitrogen, argon, and other gases. Lastly, we have the Cebu Premier Industrial Gases Corporation. CPI Gas is located, as mentioned, in Cebu, Philippines. As a whole, CPI Gas is working in gas stations, corporate management, scientific, and technical services activities. They produce and sell industrial oxygen, compressed air, medical oxygen, acetylene, argon, nitrous oxide, and nitrogen.
So, good day. In this part, I will discuss the common products associated in the industry for industrial gases. So, one of the common industrial gases that are used in the industry is helium. So, helium is used in for many different purposes, such as in MRI units. And helium is used to guarantee the superconductivity of magnets in MRI units. And in addition, helium is also essential in the deployment of 5G and fiber optics. And in addition, helium is also used in research, primarily in nuclear fusion and particle accelerators because of its low boiling point. So nitrogen is a very abundant gas, and nitrogen or compressed nitrogen is used in food packaging as a preservative. And nitrogen is also used to prevent fires in chemical plants by lowering the oxygen level. In addition, nitrogen is also used in CPUs to prevent overheating. So in the industry, nitrogen is used in pipeline drying by displacing unwanted chemicals. It is also used to displace hazardous gas from process systems, and also used in pressure tests of safety equipments. In addition, oxygen, another widely used industrial gas, uh, because of its many different purposes and its properties, it is also used as a raw material for oxidation processes for compounds such as ethylene oxide, propylene oxide, and other compounds. And oxygen is widely used in the steel manufacturing industry. Uh, the steel manufacturing industry use oxygen to increase the combustion in their furnaces and blast furnaces. In addition, oxygen gas is also used for medical purposes, in surgeries, inhalation therapies, and for respiratory problems. Uh, Also, in paper manufacturing, it is also used as a bleaching chemical. And there are a lot of uses of oxygen, not only.
In this part, we will be talking about the process flow diagram of the production of industrial gases. So, to simply explain what is happening in this flow diagram of the manufacturing of oxygen and nitrogen by the Leeds process, using an apparatus, air is first pumped and then compressed at a given pressure at the compressor. And then this passes through the condensing coils in the apparatus. Consequently, the air is cooled and water vapor condenses to form water, which is removed from the receiver. Then the air expands in the expansion tank at a given pressure. Then this is cooled because of the Joule-Thomson effect. As this cold air moves up, it further cools the incoming air. So owing to that the process is repeated of times till it ultimately cooled the air to such extent that it liquefies, the liquefied air gets collected in the liquid storage. So subsequently, the process of distillation occurs. Remember that air separation is one of the processes involved in obtaining industrial gases. So through distillation, the separation of gases is done, wherein its purpose is to extract one or both elements of the air. Given that distillation process is done, oxygen and nitrogen can be acquired at the end of the whole process. Next is the production of acetylene gas using calcium carbide. To start, acetylene is produced by the reaction of calcium carbide and water in the acetylene tank. Take note that this reaction is highly exothermic in nature, and so hot acetylene gas exceeds the main generator and enters the condenser, which operates at a lower pressure. The temperature of the acetylene gas is lowered by the heat exchange with surrounding cooling water that is circulated in the condenser. Subsequently, it enters the low-pressure dryer, which is charged with calcium chloride that absorbs and removes further quantities of moisture of the acetylene gas. Next, it enters the purifier, which is essentially a two-layer purifying chamber filled with chemical mixtures that are designed to eliminate the phosphorus and sulfate compound which are present in the acetylene gas. After purification, acetylene gas is ready for the scrubber. In here, the acetylene gas is washed thoroughly with water to remove the particles of purifying chemicals including ammonia. After that, the moist of acetylene gas enters the compressor and is compressed to the required pressure and then passed through the high pressure dryer. In this vessel, the acetylene gas is cleansed of lube oil, vapor, and moisture contained in the gas. A check valve is introduced at a set pressure so that the valve opens to the cylinder filling system after this desired pressure is reached. Lastly is the filling of the acetylene in the cylinder. During filling, a continuous spray of cooling water is kept on the cylinders to avoid temperature rise and to allow better absorption of acetylene gas and acetone with more density. After filling is complete, the cylinders are taken out by disconnecting the connections to the cylinder, and the cylinder are weighed on a weighing machine to determine the quantity of acetylene filled in the cylinders.
Moving on, the statistics about the industrial gases will be discussed in this part. Since industrial gases are composed of different types, each has their own purpose that also determines the quantity of demand they are having. It is known that 2020 is the year of the pandemic outbreak, where various economies have been greatly affected due to the sudden inevitable changes in activities and even in the workspace. Due to this, it can be seen that in the first figure, that oxygen had been the highest in the market, more than a quarter of the whole, because of its benefits and functions in the medical field that are significant for this pandemic. Other than this, nitrogen gas is also large in the market, followed by non-specified industrial gases that may be compounds derived from the production processes of the identified industrial gases. And next is the figure showing the quantity being produced by a specific company, Air Liquide. Air Liquide is a French company known in producing and supplying industrial gases, although also the largest production plant of oxygen worldwide. Specifically, its oxygen gas production reaches an approximate of 5,000 tons per day, where it is then used for various industrial purposes, such as those of the medical and the chemical uses. Then, for the table, the top exporters of oxygen gas used medically is presented here, where the highest export is Belgium, followed by France and the European Union. Germany and Portugal also had the highest exports next to France and EU, where the amounts or quantities distributed have been specified with 48.3 million cubic meters and 28.5 million cubic meters respectively. These have been the exports in the year 2019. For the last figure, it presents the total production and consumption quantities of hydrogen gas, but we would be focusing only on the production statistics. There are different ways in producing hydrogen gas, and it is shown here how much was created in the year 2019 worldwide. The production of hydrogen gas from natural gases is known to be more and approximately 69 million tons, which is much higher than its production through the byproduct of chemical processes or as minor products of industrial operations used for different substance production or for different substances production that had about 48 million tons of hydrogen gas. Since natural gases are made up mostly of hydrocarbons, large quantities of hydrogen are present and can be taken from these, thus making it a more convenient process in obtaining them.